Hey guys, hello everyone. Welcome to Rasayan Academy once again. So guys, in this channel, on the Rasayan Academy channel, you can find a lot of important concept that's going to help you in the preparation of CSI and NET examination, as well as GATE examination, IIT JAM and TIFR examination. Also guys, I am teaching full time on an academy, and there I have launched another new plus course, as you can see. Okay, and this course is basically for your next exam preparation. So a lot of students have been waiting, ki ma'am, when are you going to start everything from the very beginning? So this is it, organic and inorganic chemistry. I'll be teaching these two subjects, all the important topics of these subjects, and the first topic that we are starting from tomorrow, June 2022, is organic reagents. Okay, so for all those students who have been waiting for this kind of a course, a complete course on the organic and inorganic chemistry, you can join up an Academy Plus by using my referral code, that is Jagriti S. And if you are having any doubt regarding this, you can message me on Telegram. Okay. Yes, the classes are going to start from 22nd of June, and the class timing is 10:30 a.m. If you are able to attend the live session, it is great. If not, you can see the recording also. All right, and I'll keep on adding the practice once we study the concepts. Okay, chalo guys. So moving onwards to the questions. So guys, we are practicing questions from June 2017 paper, and once we complete these, we will be looking at questions from the December 2017 paper also. Okay, so first question on the name reaction series is, the major product formed in the following reaction is. So just looking by the reagent, just looking at the reagent, you are able to identify what is this name reaction, isn't it? This is Birch reduction, lithium and liquid ammonia. Birch reduction is basically single electron transfer mechanism, and first of all, the lithium is going to transfer electron, but where? That is the question. Is the benzene ring going to be reduced? Absolutely not, in the presence of pyridine, which is more electron deficient. Okay, so pyridine is more electron deficient, and the electron is transferred in such a way that the anion will be on the electron density will be on the nitrogen in this way. Okay, so the radical anion is going to be like this. Okay, this is the nitrogen itself. Yes, and you will know that you are going to get 1,4 reduction. So B is going to be the correct answer, not C and not even D, because 1, 2, the radical and the anion will not stay like this. Okay, this is absolutely wrong. So answer is option number B for the first question, Birch reduction, June 2017. Next question, very very simple guys. All the questions stop and try by yourself. Okay. The major product formed in the sodium ethoxide mediated reaction between benzophenone, that is this molecule, benzophenone, and ethyl chloroacetate. So it is ethyl chloro CH2COOET, that is acetate. So what can be the reaction between these two molecules in the presence of a base like this, right? Yes guys, very simple reaction, do it by yourself. So this OH minus can remove a proton from here. There are two hydrogens which could be enolized, isn't it? These are the only enolizable protons, so they could be removed. And what do you get? Get a negative charge over here, the O minus, the carbonyl bond opens up, O minus, two pH groups on this carbon. Yes, you have a leaving group, and then you have CO2 ET. Have you seen this reaction before? By now you must be able to remember. Yes, this is your Darzan glycidic ester synthesis, because here you are going to get the epoxide. What is this reaction guys? It is alpha beta epoxy ester. Okay, you are getting the alpha beta epoxy ester. Your answer is option number C. This is your Darzan's glycidic ester rearrangement. Okay, glycidic ester rearrangement. All right, very nice name reaction once again, June 2017. Another important name reaction, the major product A and B formed in the following sequence are, June 2017 once again. So do this by yourself guys, absolute easy question. CH3P CBr4. This combination, always whenever you see this combination, it is always used to form this kind of a elide system. Okay, this kind of an elide system. Okay, either you write it like this or you write plus minus, it is the same thing basically. All right, and in the presence of zinc, the elide is going to form. So the first reaction that you do over here with the CHO is the attachment of the elide. It is just going to be the Wittig-like reaction. First step is just the Wittig-like reaction, and you are going to get this molecule. Okay, and it is present in option number A and option number D. Only the Wittig reaction has happened. Two bromines are there, they are going to stick. Okay, followed by that you have N-butyl lithium, two equivalents. What are you going to do with two equivalents of N-butyl lithium? Let's see. This reaction was uploaded recently, guys. I hope that you realize what is this reaction. 1 mole of butyl lithium is going to remove this hydrogen. Beta elimination would take place. Yes, it is beta elimination only, although it is not the E2 elimination because there is already a double bond, right? So this is beta elimination, and 1 mole helps in the formation of alkyne. Now this alkyne can undergo, in 1 more mole of butyl lithium, the alkyne can undergo halogen exchange. Okay, and the BuBr eliminates. BuLi is given minus BuBr. Okay, so this is your byproduct, butyl bromide, and you are getting the alkyl ya fir alkynyl lithium. This is the molecule that is prepared till this step. Till this step, minus 78 degrees centigrade required for butyl lithium. Okay, till this step you get this. Now there is carbon dioxide, the electrophile. Definitely there is a negative charge on this alkynyl carbon. It is going to attack on the carbonyl, and you are going to get hydrolysis, which means carboxylic acid. So this is the correct answer. The reaction is Corey-Fuchs reaction. Okay, Corey-Fuchs reaction, we have done it already. Very, very simple reaction. And as soon as you see these reagents, you are able to, recognize very simply. Wittig reaction will be the first step, and second step will be the removal of both of these bromines, leading to an alkyne. And some electrophile is also needed. Either you want to add CO2 or some other electrophile, you'll know. Okay, so Corey-Fuchs reaction, answer is A. Moving onwards to next question, awesome question from June 2017. These kind of questions are very scary to look at, but then they are so easy to do and very direct question. Intermediate A and B formed in the following reaction sequence are. Guys, very recently we have done this question, so I hope that you should try this by yourself. First thing, yes. So you are having this oxygen going to attack on this carbonyl DCC and DMAP. What is the use of DCC and DMAP? They are coupling agents, and they are usually either used for the formation of the peptide bond, that is the amide linkage, or for the formation of ester. So in this case we have COH and this oxygen source, so it is going to form the ester, right? So I am directly going to write that the product is C double bond O. This oxygen has come from this molecule. It is not going to collect from sulfur because of the hard interaction. That is why sulfur is a soft species. It's not going to interact. So the remaining molecule will be as it is. Okay. So what next? Let's say, yeah, there is a double bond over here in this way. All right. Chalo. So let's say there is a negative charge on the sulfur and there is a positive charge on the nitrogen. Though what happens is, let's say we write it like this only, or like this. Double bond S, then there is one bond over here and here in this way. Alright, then what is going to happen in the presence of this molecule, tributyl tin deuteride, AIBN. See guys, AIBN, this combination we have already studied the reaction You must identify. Yes, if you identify the reaction, then you will be able to see the video on this reaction also. Alright, so this bond is going to open up from here, right? And the pi bond opens like this. Alright, you are going to get the carboxylate radical on this side. Absolutely, guys, it is Barton radical decarboxylation. You have a radical, carboxylate radical, and the rest of the molecule is like this. You have nitrogen, and these bonds are as it is. You are forming a bond over here. Okay, one sulfur and tin bond. So this is a soft interaction. That is why the sulfur and tin bond is formed more easily. Okay. Yes, and that would not have happened with the oxygen, right? So now this carboxylate radical can break down to eliminate CO2, and that can give you this kind of radical a radical on this position where there was COOH group. So this is CH3, and here below you have a hydrogen. So this molecule is now just going to grab a deuterium from here, a radical, and the position could be above or below, right? That's why the wiggly line is present. Answer is option number D. First of all, you are going to get this kind of an ester. The ester attacked by the radical, okay, is going to do the elimination in this way, and your final radical, alkyl radical, will take a deuterium. So answer is option D. What is the name of this reaction? It is Barton radical decarboxylation. Okay, radical decarboxylation, very recently done. Next easy question from June 2017 is over here. Major product formed in the following reaction is. So, guys, this is a trans decalin type system. What you have to do is just draw it in the trans decalin type. So, yes, look at the reagent. You must be able to identify the name reaction. Okay? Yes, because it is very direct and easy. So by now you must have realized how easy this topic is. If you just remember something, few things only, you will be able to answer very nicely. This oxygen is above, okay? So I'm writing the O above. What will happen in the presence of NaH? The hydride base is going to remove the proton on the oxygen, and then it is going to attack on the carbon disulfide, which is right over here, which will attack on the methyl iodide. So O minus it will be. O minus after the proton loss is going to attack on carbon disulfide, which attacks on the methyl iodide like this. So you will get the xanthate. Yes, absolutely. You are going to get the xanthate, SME, just like this. Okay, and xanthate in the second step, dodecane and heat. So this dodecane is just a solvent, all right, alkane solvent, so that higher temperatures could be reached, and heat. You are just heating the molecule, nothing else. So in the presence of heat, it is a syn pyrolytic elimination reaction, or you also call it the Chugaev elimination reaction. Okay, going through a six-member transition state. Now, on this carbon, the hydrogen is available below, and here the hydrogens are available above and below both. So, you are going to cause the elimination from this side. Okay, although the carbon after elimination won't be written in this way, but anyways, just for understanding, we can write it in this way also. So, this is going to be the double bond that you have. Okay, so the position of the double bond is not on the methyl, right? It is one step away from the methyl. Okay, as you can see, it is not like this, it is wrong. Also, it is not on the junction carbon, it is not over there, it is away from the methyl, away from the junction, right? Answer is option number C. And in option number D, you don't even have a double bond, so no, that's not going to happen. So the correct answer is option number C, to give elimination June 2. Next important question, question number 86. The correct combination of reagents to affect the following reaction is. Now, you see, guys, one very important thing over here. Okay, what are the changes which are taking place? See that first. OH has gone from above to below. Second thing is CHO has been reduced. CH2OH. These are the two important reactions. Now you have to understand the sequence of reaction. Okay. Okay, all right. So let's say if we have let's say the some reaction, okay, which will convert the OH above to OH below. If we do that first and then we reduce the aldehyde, it would be better, or first reduce the aldehyde and then convert it to OH. So guys, see, if you first reduce the aldehyde, the molecule is going to become like this. If you first reduce the aldehyde to CH2OH, the molecule will be like this. Okay. Now, if you are doing the reaction which will convert the OH to below, then the same reaction could happen over here also. So that will be a wrong process. You cannot reduce the CHO first, so you have to reduce it later. Okay, that is the selectivity. Now, what is the reaction, guys? It is absolutely Mitsunobu reaction. Yes, and you have to look for the dead molecule, isn't it? The PH3P, that is your phosphine molecule, dead molecule, and any nucleophile having a protonated oxygen group. Okay, so if you are using in the first step, if you are using this, you are doing this reaction in the first step, all right, you are going to get the benzoic acid as the nucleophile. So this is your benzoic acid as the nucleophile, right? And in the next step, that is reduction, that is hydride transfer. The hydride will be transferred over here as well as over here by lithium aluminum hydride strong reducing agent, so that both of the groups are reduced altogether. Okay, both of the groups are reduced together. So this is your final product. Okay, after obviously after the aqueous workup. So this is what you are going to get. The answer will be option number C. And I have also told you why are we following this sequence, Mitsunobu reaction followed by. So guys, you must have realized that the name reaction and organic reagent, these two topics are always mixed. Okay. So along with the name reactions, I'm also helping you do the organic reagents and revise these questions very. Another beautiful question from June 2017 is the correct combination of reagents A and B to affect the following transformation are. A little bit tricky, but we have also studied this name reaction, which will be required in this question. Let's see. First of all, guys, you are having this norbornene system. To the norbornene, you are doing the cis dihydroxylation above and the same cis dihydroxylation below. What is the driving force of this reaction? Let's see that. And how is it possible? So first thing, if you are transferring the OH from a bulky group, it will happen and it will form the exodiol. Here you are getting the exodiol, and B may you are getting the endodiol. Okay, let's first look at the possibility of exodiol formation. That can happen with catalytic osmium tetraoxide and NMO. This is possible. Secondly, also it is possible with the alkaline KMNO4. So these two options are looking correct. However, option number C, iodine and silver benzoate and aqueous NaOH, this is a Prevost reaction. Prevost, you don't have cis. Prevost has a trans dihydroxylation. Dihydroxylation is basically for the trans system. You don't have it. Metachloroperbenzoic acid will form the epoxide and that will also give you the trans diol. Okay, so C and D both are absolutely wrong. Let's try out with option number A. In option number A, this part is correct. Okay, you can get the exodiol very well. But the second part is wrong because once again you don't have water over here, and this again is going to lead to trans-diol formation Prevost reaction. In the second example, option number B, the alkaline KMNO4 is going to transfer the oxygen in this way. Alright, it can do that. It can transfer the oxygen in this way from the exo only because this group is very bulky. But in the second part of the question, you are doing the Woodward cis dihydroxylation because first of all, the iodine is going to add to this double bond. Yes, and then the silver acetate, या फिर silver benzoate is given. That is going to attack from the below, from the endo position basically, that is going to attack. You are getting the carboxylate which is free to attack from below like this. Okay, carboxylate is going to do NGP in this case from below endo position. And when you are doing the hydrolysis, because there is water in this case, so water is going to, or let's say I'm writing OH2, not D minus, the water is going to attack on the carbonyl itself. Okay, and it is going to hydrolyze these bonds right from here. It is not going to do any other reaction on these two carbons. It is going to attack the carbonyl carbon and directly do the hydrolysis to give you this kind of a molecule, the endodiols. So Woodward cis dihydroxylation present in option number B. And the first part is just alkaline KMNO4 forming the cis diol. Okay, so you can just check out the Woodward and Prevost reaction from the name reaction list. Answer is option number B. Another name reaction from June 2017. Okay, so mixture of name reaction and pericyclic. All right, so yes, following reaction involves, see what you are going to do over here, an aldehyde, and you see a secondary amine. This is a secondary amine, only one proton could be lost. So first of all, you are going to make your CH. You are going to make the iminium ion. Here you are making the iminium ion. This is your iminium ion. Okay, followed by, now what are you going to do? You have formed the iminium ion, right? And what are you going to do? Let's say this, yes, iminium ion has is like 1,5 die in 1, 2, 3, 4, and 5. Yes, I've written 2 OH. This is, yes, okay, right. So you can do a 3,3 sigmatropic rearrangement in this way. That 3,3 sigmatropic rearrangement, when it is the 1,5 diene system, it will be cope rearrangement, and within the 1,5 diene system chain, if you have nitrogen, it will be azacope. Okay, so first you are doing the iminium ion formation followed by the azacope 3,3 sigmatropic rearrangement that is going to give you, right, single bond with a nitrogen, one double bond over here, one double bond over here as well. This is going to form a bond. Okay, you have OH, have the CH3. Oh, sorry, this bond is going to open up. Otherwise, it will become pentavalent, isn't it? Yes, now you are having this enol system. The double bond is going to attack directly on this carbon. And what do you get? Let's write it over here. One double bond O, one CH3. This and this is a double bond. You are getting a 5-member ring from here, COCH3 as it is, and nitrogen for methyl. So this is exactly the molecule that you wanted. So we are doing the azacope followed by the manic reaction. Okay, we are not doing the aza-aldol reaction. It is a manic reaction. So answer has to be option number B. But one step is extra. You are first following the iminium ion, but that's not asked. So this is your correct answer. Okay. Now the questions start from December 2017, guys. If you know, in June 2017 there were many questions on name reactions. So in December 2017 I found few questions. Yeah, that happens alternative years. So yes, try this out. Major product in the following reaction. First of all, we are going to convert the carbonyl into the hydroxyl amine this way, right? Okay, now you want to keep this OH group away from this methyl, isn't it? Because because of the bulk. Yes. And in the second step, this is converted to the acyl group protection of the. Yes, we are doing the protection of the oxygen, and it is going to be converted to acyl group like this. Now that also makes it a good leaving group, isn't it? OH is not a good leaving group, but if we attach, let's say, phosphorus to it, PCl5 or PCl3, and if we add tosyl group or any other group, if somehow we make this oxygen a good leaving group, it is going to drive this reaction forward. What reaction? Usually it could be Beckmann rearrangement, but since the fragmentation possibility is giving you a stable tertiary carbocation like this, and also there will be a release in the ring strain, so CH3CO, the leaving group is also a stable organic entity, so this is what you are going to get. All right, this is your molecule. Further, you can remove a proton because the acetate can take away a proton. Which proton you want to remove? This is CH3 proton and this is CH2. So absolutely you want to remove this proton to get you the more stable, give you the more stable system. This is your CH2 right over here. So the double bond will be like this is no more a bridging position. This is a simple molecule like this. All right, don't confuse this. It is not a bridging position. It has to be option number. Your Beckmann fragmentation. Okay, very beautiful reaction. Next important question from December. See guys, 1 year 2 fragmentation reactions have been asked. Are very important. Now alpha beta epoxy carbonyl. If you see that already, if you see a tosyl hydrazone, what are you going to think of? Yes, now you must be educated enough to think about what is going to happen. You must just remember okay, this reaction, I know what. I So you have formed the hydrazone in the first step, and in the second you have a base is molecules will usually have this kind of a setup. One is the Vatine reaction, which was asked in the previous year. This is not Vatine, this is absolutely right. It is are going to break this whole ring while over here. Other thing, you are going to form alkyne, which has to be your molecule. Further, it is your basically the product of fragmentation, which you get in option number one. Okay, so yes, present. Now second thing that you see is you are having the catalytic hydrogenation in the presence of calcium carbonate, that is the poison, catalyst poison. Reduce this, right, this whole system in the alkyne, but alkyne should give you the transalkene, it is wrong. Then this is also a transalkene, it is wrong. This alkene, check the position. The first part is absolutely correct. Okay, correct. Going to be the correct answer. Alright, you're getting the cis alkene, not the trans alkene. What is wrong over here? The file group is not going to be close to this. Absolutely wrong. Your correct answer. Eschen-Mosher fragmentation. Out the video for this also. Now, very easy reaction, right? For these kind of reactions, I don't even want to do a mechanism, but then Yes, maybe some of you are seeing this for the first time. Be careful about the carbene that you are preparing. The presence of methyl lithium. Now, methyl lithium is working as a base. I'm not saying that it is not going to remove this, but when I'm taking this in for alpha elimination process, your carbene. Now, when the carbene inserts the double bond, carbene can insert into this double bond. Nitrogen is going to in this bond because there is a Cl minus which can expansion takes place and there will be no Cl over. This is the this is the Shamshan density rearrangement, and you have also seen one similar question where there was chloroform, but this is not chloroform, dichloromethane, so there is no take care of the carbene that you are synthesizing. Your correct answer. Alright, another question from December, very easy to do. First of all, you guys have a terminal alkyne. So the terminal alkyne has a butyl. Where is where are you going to do hydroboration reaction? You are going to do the hydroboration just like this. In addition gives you hydrogen added over here. The other hydrogen was already present. Okay, and this is your boron B catechol borane. Second step is hydrolysis, which is going to give you basically the same system, but hydrolysis of borane to be twice. Now this is ready to do the transmetallation with this species. Now this species will first of all give you palladium inserted in between the carbon boron bond, oxidative addition. Transmetallation is going to give you transmetallation followed by reductive elimination gives you the like this. So I'm just drawing the skeleton. Yes, it is going to be a cis alkene. This is your product. Okay, this has to be the product. So first one, these two are correct about the first. These two are wrong because you are going to get trans alkene in this way. Followed by this alkene should be cis as it is. So B is going to be the correct answer. Yes, guys, it is the first step is hydroboration and then hydrolysis. Second step is the Suzuki coupling. Okay, very direct questions on Suzuki coupling. So B is going to be your correct answer. We have done plenty of good questions from the June 2017 and December 17 paper. Alright, and you can check out the paper for more such questions. Also guys, more as you know, we are doing a series, so more important examples of next year are coming up. And if you already, if you have not yet subscribed, please do. Also share it with your friends and